So what if I told you that the way we build software just fundamentally changed? Like, completely changed. We are officially stepping away from those tedious manual workflow builders and entering an era where you can generate full-stack, autonomous AI systems in a matter of minutes. Today's explainer is going to show you exactly how this magic happens, and more importantly, how you can actually use it yourself.
Here's a quick look at what we're covering in today's explainer. First, the rise of Vibecoding. Second, anti-gravity and agentic systems. Third, the 5-step BLAST framework. Fourth, the universal remote MCPAs. And finally, triggering and deployment.
All right, part 1, the rise of Vibecoding, a paradigm shift.
Okay, so Vibecoding, what is it? Basically, it's the process of coding with natural language, allowing you to direct agentic AI models to autonomously build and deploy complex, full-stack applications. We've rapidly moved past those clunky drag-and-drop platforms. Now, your voice or just your everyday written language is literally your keyboard. You just describe what you want the software to do, and the AI agents go out and actually build the infrastructure to make it happen. It's wild.
To really get this, think about the old way. We used to build automation using node-by-node workflows, just these glued-together steps that usually turned into a really slow single-agent bottleneck. It's kind of like a single chef in a kitchen trying to cook a massive 5-course meal, one dish at a time. It works, sure, but it's slow, and if they burn the soup, the whole dinner just pauses. Well, the new way is Vibecoding. It uses parallel multi-agents and self-healing automated logic. So now it's like upgrading to this fully staffed world-class kitchen where 5, 6, or 7 specialized chefs are all working on independent dishes at the exact same time, adjusting on the fly if a recipe needs a tweak.
Moving right along to part 2, anti-gravity and agentic systems, the IDE.
So the engine powering this entire shift is Google's anti-gravity. The source material perfectly describes it like this. Anti-gravity is our jet from the future, and the pilot is who we can change. Think of it exactly like an advanced fighter jet. You can easily swap out the pilot based on exactly what you need, whether you're plugging in Gemini for some front-end design or Claude Cody for really deep troubleshooting. And this flexibility is absolutely crucial. It helps you avoid a little something developers call context rot. Context rot is basically when the AI just gets overwhelmed and starts forgetting the main plot because its short-term memory is totally full. Kind of like you or me trying to hold 50 random phone numbers in our head at once. By changing pilots, you keep the flight smooth and stop the system from getting stuck in these endless thinking loops.
Honestly, imagine hiring an intern with a 500 IQ. They don't sleep, they don't take coffee breaks, and they have flawless access to every single one of your files. When you're using anti-gravity, that is literally what you are doing. You have this genius intern who knows everything about your specific business logic and just executes parallel commands without breaking a sweat. It's like having the smartest person on the planet sitting right next to you with all the tools they need to build exactly what you ask for, literally at the speed of thought.
Which brings us to part 3, the 5-step BLAST framework, your build spine. Now, even a 500 IQ intern needs clear instructions, right? That's where the BLAST framework comes in. It gives your AI a strict master prompt to work from. The steps are blueprint, links, architect, stylize, and trigger. Why is this so important? Well, AI models are inherently creative, which means they can be a bit random. By following this exact methodology, you stop the AI from hallucinating wild outcomes and instead force it to produce reliable, rock-solid results every single time, whether you're spinning up a website, an onboarding system, or a custom Notion dashboard.
Let's break it down. Step 1, B is for blueprint. This is where you establish the ultimate North Star for your project. You map out your integrations, lock down your source of truth, define the delivery payloads, and set some strict behavioral rules. To translate that a bit, delivery payloads just means telling the AI exactly what specific info needs to be handed off at the very end of its task. And source of truth? That's pointing the AI to the exact database that holds the correct facts, so it never has to guess. You feed anti-gravity this blueprint to outline your exact vision, because without it, your genius intern has absolutely no idea what they're actually trying to build.
All right, part 4, the universal remote MCPs.
MCP stands for Model Context Protocol. It's a standardized connector, but honestly, just think of it as a universal remote control that lets your AI agents securely read and edit external apps. It is pretty magical. One single protocol allows your custom AI to effortlessly read your Notion docs, grab a recent meeting transcript from Fireflies, and then neatly drop all of that structured data straight into Superbase. And the best part? You do all of this without writing those custom, fragile API integrations for every single app.
Setting these up is a breeze. You can grab these connectors straight from anti-gravity's built-in MCP marketplace.
But hey, if an app you need isn't there, no need to panic or start coding. Just ask ChatGPT or Gemini to generate the exact technical hand shape you need to connect it. A quick pro tip for you here though. Limit your active tools to a maximum of 50. You really want to preserve the AI's context memory window to keep it focused. Oh, and always create virtual handshakes to double-check the data is flowing correctly before you tell the system to go ahead and build out the full logic.
Jumping back to our framework, step 3 is A for architect. This step is entirely about forcing probabilistic LLMs to follow strictly deterministic business logic. Think of it like this. Language models are probabilistic. They're like creative artists, constantly guessing the next best idea. But your business logic, that needs to be deterministic. It needs to act like a strict accountant, where 2 plus 2 always equals exactly 4 every single time. The architect step forces the creative artist to act like the strict accountant. It lays down the underlying plumbing so your apps don't just fall apart like a cheap suitcase the second a customer actually clicks a button.
Picture this architecture as a 3-story building that perfectly separates concerns. On the top floor, you've got your technical SOPs, which clearly define your goals, inputs, edge cases, and golden rules. Down on the middle floor is navigation. This is the reasoning layer that acts kind of like a traffic cop, routing data between tools without trying to do any complex math itself. And finally, on the ground floor, you have Python tools. These are deterministic, testable scripts meant for pure execution. By keeping these layers separate, if your business rules ever change, you just update the SOP document up on the top floor. You never have to touch the Python code on the ground floor, meaning the AI won't accidentally break your whole software just trying to update a simple rule.
Step 4 is S for stylize. Because let's be real, an app that works is great, but nobody wants to use something that looks like it was built in 1998. This is where you format rich outputs and refine your UI and UX components. You actually use a technique called UI sniping, literally grabbing gorgeous pre-built code components from open libraries like CodePen or 21st and just dropping them straight into your front end. These libraries act like a high-end visual wardrobe for your AI to dress the application in. The goal here is a completely frictionless experience where the user doesn't have to overthink the interface for even a second.
And finally, part 5, triggering and deployment, running autonomous code. T is for trigger. This step takes all that beautiful code off your local machine and pushes it out to cloud infrastructure so it can live and breathe on its own. You might deploy background scripts via Modal to run cron jobs, which, by the way, is just developer speak for a task scheduled to run on a strict timer, like, say, scraping a competitor's website every 3 hours. Or you could push your full-stack apps live to GitHub and Vercel, which acts as the public stage so anyone in the world can access it. Ultimately, it's about making sure your autonomous code runs reliably, around the clock, whether you're sitting at your desk or out at the gym. By stringently following this BLAST framework, you're not just making some fun little experimental toy. You are vibe coding incredibly valuable full-stack applications tailored exactly to your business. Think about a fully automated meeting tracker that instantly updates your CRM, or a completely custom data dashboard for your team. You are autonomously generating software that would easily cost an enterprise $10, $20, or even $50,000 if they had to hire a dedicated team of developers to build it. So, as we wrap up this explainer, I want to leave you with a thought. Knowing that you can deploy these self-healing parallel AI agents using absolutely nothing but your words, what massive workflow will you replace first? Now that you literally don't need to write a single line of code to build complex software, what autonomous system are you going to spin up today?